Welcome. Today we'll explore an interesting pattern that emerges when we take repeated derivatives of a trigonometric function. Let's start with the function y equals 4 sine cubed x, which can be rewritten as 3 sine x minus sine 3x. Let's understand what happens when we differentiate this function repeatedly. Taking the first derivative with respect to x, we get y1 equals 3 cosine x minus 3 cosine 3x. Now, here's where it gets interesting. We can rewrite this using the trigonometric identity that cosine theta equals sine of theta plus pi over 2. Let's visualize how this pattern develops. For each derivative, we'll see two key changes. First, the coefficient of the second term gets multiplied by 3, and second, the angle inside the sine function increases by pi over 2. Let's highlight the key observations in this pattern. Notice how the coefficient of the second term follows the pattern 3, 9, 27. These are powers of 3, and the angles increase by pi over 2 each time. Pi over 2, pi 3 pi over 2. This leads us to our general formula for the nth derivative. The nth derivative will be 3 sine of n pi over 2 plus x minus 3 to the n power times sine of n pi over 2 plus 3x. To verify this pattern, you can continue taking derivatives and observe that each new derivative follows this formula. The beauty of mathematics lies in finding such elegant patterns. And there you have it. We've discovered and proved a fascinating pattern in the repeated derivatives of our original trigonometric function. Thank you for watching.